All right, so this is what the assignment's going to look like. Lots of fill in the blank. We're starting with the function. The first thing we're going to do is use our calculators to help us graph the function and put it on the graph, and then we'll do all of the describing. So you hit your y equals key, clear everything out,
Y equals?
and we're going to type this in. So 2x to the third minus 6x squared minus 8. So to look like that,
Hi.
mark.
Okay, I'll take it.
So let's go ahead and graph it. And this will be set up the same way that this graph is. It's from -10 to 10. And we can see it goes actually a little bit off the graph. So if that happens on a normal screen, we actually want to change the window just slightly so that our y values go lower. We don't need to change the x's at all. So I'm going to make my y minimum go down to, I think -20 will work. Just so I can see exactly what that shape's going to look like. And now we have a little bit better idea. So it is going through the y-axis at -8, which makes sense. That's what this -8 at the end does. So I'm going to put a point through at -8. And that's actually where this little hump is. And so it's going to go down like this. And then we need to figure out how low this goes over here. So you could use your trace key and sort of estimate. It's going over, so at about 2, it looks like it's at -16. So I'm going to add to my graph just a little bit. Sorry, this is a standard graph. So 11, 12, 13, 14, 15. Here's -16. And so over here at 2, it's going to go down here. And then we are going to need to know that because that'll be one of our minimums. And then we need to just approximate where it's going through the x-axis. It looks like it's like a little bit more than 3. So I'm just going to go a little bit more than 3 like that. And so now I've got a graph that I can work with to answer my questions and proof that you graphed it. So looking where it goes through the x-axis, y-axis, and just where these maxes and mins are on the graph, those are the points that I would look at checking assignments just to see if we have those important points. So this is a third-degree polynomial function. We actually haven't gotten into that a lot this year. We did a lot last year. So polynomial functions are the ones that just have x's with powers. There's no fractions or roots or anything weird. And the third degree, that's just the highest power of x. So this isn't radically new, but I don't know that we've talked about that in as much depth this year as we did last year, so I'm just pointing that out. And then we can go through, and the rest of this is stuff that we've done in this unit. So the domain is, so looking at this, what is my domain? From left to right. Negative infinity to positive infinity. It goes forever to the left and forever to the right. It just keeps going. And technically the range would also be negative infinity to infinity. On polynomial functions, well, sometimes it isn't on the range, because sometimes if it's a parabola or something like that, it can have a max or a min. But this is basically just goes on forever in all directions. So this function has no symmetry. And then this isn't supposed to be here, so we're going to cross that off. Sorry. The graph has a blank it's supposed to say minimum. It's minimum. I don't know why I spelled that wrong, but I did. That U shouldn't be there. So does it have an absolute minimum? No. We just have a relative minimum over here. So we're going to put, it's a relative minimum at, or I should say of, -16 at x equals 2. I'm going to reword that. And a relative maximum, and I'm going to change the wording here, of -8 at x equals 0. So this is my max, and down here that's my min. They're relative maxes and mins. They don't have absolute maxes and mins because the arrows go forever on the ends. The graph has no absolute maxima because the graph goes up forever. It has no absolute minima, and because the graph goes down forever, except evidently I have a lot of typos, sorry, because the graph goes down forever. So the graph has zeros at, it only has 1 0, so I didn't actually need the second blank. And it's between 3 and 4. Instead of just guesstimating that, we can use the calculator to figure out what that is. And so I'm going to go into second and hit my trace key that goes into the calc menu, and I want to find the 0. And so it's going to say, okay, left bound. So the 0 is right here where it crosses the x-axis. I can just click on a point a little bit to the left of that, and then I'm going to go just a little bit to the right of that, and it's giving it a very small space to search on the graph for where that y is 0, and if you just hit enter, it'll tell us it's about 3.355. So let's just round that off to about 3.4. So it has the 0 at about 3.4. And we could find the out a little bit more of that if we were using an algebraic method, but we're going to call that good for right now. All right, so the function is increasing over intervals. So if I look at it, it's increasing, decreasing, increasing. So it's increasing over the interval -infinity to 0. And also, so I'll put a little u, also from this point down here, which we said was 2, so positive infinity. And then between 0 and 2, it's decreasing. So the function is decreasing over the interval 0 to 2. So this is what polynomial functions, the kinds of stuff that you're going to do with that. Down at the bottom, I have a quick blurb just about different types of functions. Just to remind you, we did do the library of functions packet, but you probably don't have that handy because I think it's in the folder. So we'll just go over this really quick. So polynomial functions include linear, so that's stuff like y equals 3x minus 2. Quadratic, so stuff like y equals x squared minus 5x plus 7. Cubic, you have x cubed plus 4x squared minus 8. And when we talk about degree, this would have a degree of 1 because it's x to the first. This would have degree of 2 because it's second. This would have a degree of 3 because it's a third power. So here's some specific names. After you do the third power, there are other names that we've talked about in the past, like quartic and quintic, but they don't usually, you're not usually going to see a whole lot of that. So that's polynomial functions. Linear functions look like this. They're lines. Quadratic, you're going to have a parabola of some sort. Cubic is like this. And then it just starts getting more and more curvy the higher the power is. It just ends up with more maxes and mins in there. All right, so a reciprocal function is also sometimes called a rational function because rational numbers in math are ones that can be written with a fraction. And so what you're going to see is x in the denominator. So some examples of that would be f of x equals 1 over x minus 2. F of x equals x minus 3 over x squared plus 8x. And those are the ones that you're going to see asymptotes, which we've talked about just a little bit. So you might have an asymptote here, and half the graph's over here, and half of it's over here, like that. And then there's various other shapes you can get, but you'll have some lines where there's a break in the middle of the graph. Absolute value functions have absolute value in them. I know that that's shocking. So things like f of x equals the absolute value of x plus 3. And those are typically going to be a V shape unless you combine it with the polynomial or something else that's weird. Exponential functions we have done before. We haven't looked at them a lot this year. That's things like 2 to the x, and they typically look like this or like this if they're going down. Exponential growth and decay. When I taught you guys this, we talked about radioactive zombies and things like that, and we graphed the zombie apocalypse, but that's been a year ago. And then the piecewise functions are the most recent ones that we've done. That's where you have f of x and the big bracket, and they're going to have like a piece and a piece. And you end up with graphs that look kind of weird. Like you might have a piece here and part that goes over there. And so that's just giving you an idea of some of the different functions. There are others. That just gives you some of them. So we're going to do one more example where we go through and talk about them, but I'm not going to have time or space to do an example with each of these. I'm just giving you the main ideas. So this function has x in the denominator. So we're going to say that this is a rational function. You could also call it reciprocal function. There's different names for it. I'll take either. And if we graph it, we can answer all of the other questions. So let's do that really quick. So we're in the y equals menu. 1 divided by, and then for then you're going to do parentheses x squared minus 4 close parentheses. And you hit graph. And it's going to be kind of weird looking. Oh, I need to go back to my regular graph. So to go back to regular graph, you do zoom and number 6. And you'll see that there's actually 3 pieces. So there's 2 vertical asymptotes. Looks like it's at -2 and 2 are where I don't have any points. So when I go to put it over here at -2, I'm going to draw a little dashed line. And at 2, I'm going to draw a dashed line. And then I can put in the rest of this. So this part over here looks like this. And it never crosses the x-axis either. The x-axis is also an asymptote for this one. And then it comes way up here. And then it kind of slopes down like this. And then we have another piece over here that looks like this. So we're not going to get a lot of specific points on this one. The main thing is we've got those asymptotes and knowing where those breaks are. All right. So it's a rational function because it has a variable in the denominator. The domain is. There's a couple of ways you can do domain. We could do -∞ to -2, -2 to 2, 2 to infinity. Or we can use the other notation. We say x such that x does not equal -2 and x does not equal +2, which is a little shorter. So I'll put the other on here as well. You could also go -∞ to -2, -2 to 2, and 2 to infinity. I will take interval notation or set notation. I'm good with either. This one takes a little bit more writing, but some people like that better. It's just where all these pieces are, and then you're just taking the breaks out. So the range on this is, the range goes from the bottom to the top, and it's pretty much all the numbers except right here on the x-axis. So you could say x such that x does not equal 0, or you could use your set notation and say -∞ to 0 combined with 0 to infinity. We're just not including 0 when we go from the bottom to the top. It skips over 0. This is just a little bit under 0, and then it jumps to the other side without crossing. It has what kind of symmetry?
Y-axis.
Y-axis. Good job. Y-axis symmetry because it is an even function, which means that f of x equals f of -x. That's just the definition. The graph has some kind of maximum value. So what kind of a maximum value can we have? Absolute or relative? Maximum. So it looks like it goes up forever, so I can't have an absolute. So I can have a relative right here, and it's almost 0. We can go in and look at this a couple of different ways on the calculator. I could do trace, and when you do trace on a new function, it automatically starts in the middle, which is kind of lucky because it's telling me it's 0, negative 0.25, and it just gives me that point. It's like Christmas. If it didn't give you that, you could use the calculate feature and look for maximums, or you could use trace. We want to figure out what it is. So it's a maximum value of negative 0.25 at x equals 0. So I'm changing the wording there to be more like what we had in the notes. There is no absolute or relative minimum because the graph goes on forever and I don't have any valleys to look at, so there's no absolute or relative minimum. There is no absolute maximum because the graph goes up forever. There is a horizontal this is supposed to be at y equals 0, which would be the x-axis. It's a typo. Sorry, I evidently am just rife with typos. And I fixed them last year and just never got them fixed on the handout, so we'll just fix it as we go. So this is a horizontal asymptote right there. And then there are vertical asymptotes at x equals negative 2 and 2. And that's just those places where it jumps where you don't have any numbers. And you can figure those out by looking at what was not in the domain and range. And then we have the function is increasing. So this section over here, this is all increasing from left to right. It is increasing slowly and then bam, increasing quickly. So it's increasing from negative infinity to negative 2. And then if I go to this section, it's increasing from negative 2 up to 0 also. And then when I get to this side of the U-turn, it goes down, so that would be from 0 to 2. And this part's also decreasing from 2 to infinity.